Hello. Good morning. Amanda says good morning. Jesse's here. Raj is here. Hello. All right. So why don't we get started? Do we have any updates, personal or?
Not too many. I'll say a bit more later, but just preparing for the fall semester. Well, that's been on my mind. I really enjoyed the reading group, and a tie into a bunch of things. The discussion really related a lot. We didn't really have a formal Cognition Futures meeting, but the way it tied into some of the methods things and my own philosophy, history of science stuff has been on my mind a lot since then. So I did some work on that last night, and I might say more about that later.
Okay. So yeah, I didn't make that meeting, so I don't know if it was that the Thursday meeting or was there a separate meeting yet?
No, you were there Thursday.
Oh, okay. It was Thursday. Yeah. All right. Yeah. Because we have two meetings. We have the Cognition Futures.
The Wednesday one didn't happen, but like the way some of the things that caught up, we didn't go explicitly into it, but there was some overlap, like at a macro level, to some Cognition Future stuff.
Yeah, I was. Now, towards the end of that meeting, we sketched out a sort of a cybernetics paper idea, and I went to draw that out after the meeting, and so it'll have to be fleshed out in the coming months. But I actually think that it'd be nice to have maybe a way to like put our mark, like what do we mean by cybernetics and what does that look like, and it would be kind of an interesting paper.
Yeah, that there was a very interesting, and I actually have this on. I might show it later, but well, it's not really a good diagram. It was me trying to parse out some of what was on the page at that time, or on that website, like the Mimetics website, and kind of going from classical cybernetics and how cybernetics kind of was going with AI and then split from AI in terms of neural network focus, in terms of I think that was the era where like good old fashioned AI and symbolic logic became the dominant AI paradigm. One of the summers for that version of AI, I think. And then the neural network stuff and the cybernetic stuff and the artificial neural networks and all that stuff kind of was left in one space, and there was a lot of cybernetical push into like management and social sciences and sort of interpersonal stuff and that aspects of control theory. But in between that, there was sort of the Manturana, I can't say his name wrong, and Varela, and like the actual thing that would lead to like Varelian phenomenology and his work on autopoiesis, the autopoiesis work, and the like the whole phenomenological angle that would kind of come through that, interestingly enough, and embodiment. And so I think I'm curious as sort of like I know, we talked a little bit about second order cybernetics and that shift and how that led to a lot of some, I don't know if paradigmatic evolution is the right way to say it, but I'd like to explore that a little specifically in more depth my own self. And I don't know, the paper idea you said, I don't quite remember. I remember you talking about it, but I don't remember where, like, do you see it as kind of capturing that process but saying, given that development, here's where we are? Or I don't know if you have more thoughts about it since then. Or...
Well, it's not really a history or anything. It's just like some ideas about, it's like some of the phenomena that are happening in cybernetics. It's like some of the regulatory phenomena, and then it would actually be kind of interesting to have like that history, and then in lieu of that, what are some of these concepts and what's our stamp on it? So what kinds of insights can we bring to that history or that line of development, So
yeah. You were saying, sorry.
Oh no, that was pretty much it.
I don't know, like one of the strongest pulls in that, which is sort of not really active right now, is some of, I don't know how to really refer to it, Avery-ish related stuff and allostatic kinds and these in that kind of field that arena where we're starting to push some things forward, and even to the extent I think Avery's still working on some of those things in the background. But I don't think it just has to be that either. I think some things we were getting at different almost different scales will be applicable too. So yeah.
All right. Well, yeah, we can talk about that later. It sounds really interesting. So, I'd like to follow up, or it sounds like something we could do, and it would be really, I think, a good contribution to the debate. So Amanda had some updates. No Cognition Futures this week, but I worked on the embodied neurophenomenology project a little, and we'll share soon. Human use of human beings reading group is going well. Okay, and then I just put some papers in the Notion that connect Varela with cybernetics. So this is in the Notion, and yeah, there's a image here which has like the Google Doc search or the Google Scholar search of some things here. So yeah, we can do this, and we can kind of develop something here in the Notion about this, and then we'll maybe revisit it later. Nice. Thank you, Jesse and Amanda. Hello, Hussain. How are you?
I'm fine, thanks. Yeah, just thought I could stop by.
Yeah.
I've been a bit MIA, just busy with work. For those of you who I haven't kept in touch with, I just accepted a new job offer over the past few weeks. So I'm working as a consultant for a VR company, and we make educational games for kids to learn about STEM, or actually, STEAM, really. Which I never heard of that acronym before. STEAM. Apparently, the A stands for arts, and I'm like, that's. See, I sorry not to go on a tangent, but I always thought it was like, why would they do that? I thought STEM was supposed to be just for like science and math and things. Like if you add art, it kind of defeats the purpose. But
yeah,
I'll for whatever you do. But yeah, I've also been doing a few side projects here and there involving Vision OS Pro and other tools and technologies, just to continue to grow my skill set, expand things, and the job I'm working as a consultant for, and I'm actually applying to jobs right now, like other jobs too, because I have the option of switching to part-time on this one. So that's basically where I am right now. Yeah.
Well, very good. Thank you for the update. Yeah, you've been working on the Vision Pro with the developer's kit, which you can download without having the headset. So
yeah.
So
yeah, it's interesting because a lot of like companies, when you're looking for things to like start with, or like looking for experience and stuff, sometimes they can ask for like a great amount of experience with something, even if it hasn't come out yet. And it's like Apple is looking to hire Vision OS Pro engineers, even though the Vision OS Pro isn't out yet. So it's like, what are they looking for? Well, they do. They'll make things like this like public, like the Vision OS software developer kit and things like that. They make those things public, and so people can get started with that. Yeah,
that sounds great. Yeah, I look forward to seeing some of the things you're making, and just whenever you want to present on that, you can.
Yeah.
Do.
Thanks.
Yeah, I would like to give my updates.
Okay, sure.
Is my screen visible?
Yes.
Okay, so the Q-learning equation which we had. That I tried to visualize it with the OpenAI Gym library. So I'll just keep it like as general as I can. So in Q-learning, basically what they're doing is the AI is trying to generate a lookup table so that the AI can just look up and see what will be the most optimal action that can be taken. So I'll just show the code for it. So this is one environment called Frozen Lake in the OpenAI Gym library. One second. Yes, so just a second. Yes, so this is the frozen lake environment. So in this, what's happening is there is this agent. So this is the starting point and this is the goal he has to reach. And basically he has to navigate in such a way that if he falls in one of the holes, then the game ends. So without falling into the holes, he has to get to this endpoint. So for that, basically we are just setting the initial variables such as the learning rate and discount factor as required in the Q-learning equation. And there is this thing called epsilon, which I read about recently. So what this epsilon does is, in reinforcement learning, the problem is like he follows a very particular path. So what happens is there is this debate of exploration and versus exploitation. So what happens is if the agent knows that following a predefined path is getting him to some point, then he doesn't explore the environment further. He just tries to exploit the current learning that he has done. We can call it as the greedy approach. So what this epsilon does is we basically just generate a random number. We generate a random number and let's say that it can be like 0 or 1. So if the value is 0, then we just follow our lookup table. And if the value is 1, then we can just take some random action so that the agent explores the environment further and we can maybe get some more insight. So in this, what is happening is I trained this and this is the training results that we are getting. So after around 10,000, so just a second. Yes, so the epsilon value is 1 and I have kept the decay rate as 0.001. So what will happen is after one episode, like one episode is basically a iteration, we can say. So one episode can end either in two scenarios. Either he reaches the end goal or he takes 200 steps, but he doesn't reach anywhere. So that is when an episode will end. So at the end of every episode, this epsilon, which was initially 1, this is reduced by 0.0001. So that by that aspect, it will run for 10,000 episodes before it goes to 0. So while we are iterating for a particular episode, so here is the random number generation. And if it is less than epsilon, then it just takes a random action. That is either it can go left, down, or up or right. And then once this is completely decayed, then it just, like the lookup table that was generated, it just starts following that. So as we can see here, after around 10,000 episodes, the rewards on y-axis, we have the rewards. So the value of rewards are getting very high because now it has trained for 10,000 episodes and now it's just using the trained data to maximize its rewards. So as you can see, now it never falls in this in the holes basically, because what it has done is I trained it for around 15,000 iterations. So what will happen is it will always reach its end goal, as we can see now. This is one of the environment, and the other one was just a second. Yes. So basically, what was happening here is this is our queue table. This is the queue table we have. So here there are states, and over here there is actions. So the actions we just have 4 actions. Either it can be up, down, left, or right. these are the actions that are possible. And state is just the current state of the agent. So let's say if he's here, then this is his state. Like the coordinate can be his state, his current position, if we can say. So in this case, this is this is a 8 by 8 grid. So there are total of 64 states there are total of 64 states that are possible. Since this is a 8 by 8 grid, there are 64 positions where he can be at any time. So in the states, in the row of the states, we will have from like 0, 1, 2 and up to 63. So what will happen is if the agent is at 1, so let's say he's at this grid, this one grid. So what our AI algorithm will do, it will just look up at this table and it will say, okay, so the current state is 1. So if I go up, let's say the reward is 0.8. If I go down, let's say it's 0.9, and this can be like 0 and 0.6. So what it will do is it's at the current state, and the maximum reward it will get is by taking this action that is going down. So it will come down, it will come here. Now let's say this may be like cell number 30, let's assume. So it will come here to the cell 30, and here it will see that which action gets me the maximum reward. And this keeps on going for the training purposes. So once the training is done, there is this queue table that gets ready. And then once this queue table is ready, it is very well aware that, these are the steps that should not be taken, else the game ends. Same with all these other holes. So that is why in the current iterations, it never falls into these holes. And similarly, there is one more environment in OpenAI Gym called the mountain car. So just a second. Yes, so basically what is happening in this case is we have a car which starts at the bottom of the hip, and the car needs it needs to gain enough momentum so that it can go and reach this flag. So as you can see, this tries to gain enough momentum, and it ultimately it reaches the flag. And once it reaches the flag, the game just restarts. So what is happening in this case is, for this also the AI tries to generate a lookup table. So here we have the actions, and here there are the states. In this, there was some the problem with this is in the previous one we had like the grids we can just take the coordinates or the position as the states. In this, there are actually two parameters that people consider because in the position, so it's two-dimensional. So non-uniform surface, it's not very grid. So what I did is I try to distribute it into regions. So if the car is in this region, then I can call it as P0. If it is in this region, then P1, and so on. So I just distributed it into various regions. And even the velocity, since it's a float value and not an integer, it is like infinite values are possible. So I just confined it to a range of 0.007 to negative 0.07 to positive 0.07. So this was trained for just a second. Okay, I'll just do the training. So I'll just set the training to true and then the rendering to false. And I'm training this for 5,000 episodes. So once this may take a minute.
I definitely appreciate seeing the OpenAI Gym and the walking through demos. So it's cool to see that.
Yeah, this is great.
Okay, while this is training, I'll just go to the explain. So as you can see, like basically according to the current position, like position and velocity values, there are like three actions possible. Either you go left, or it stays neutral, or you can go to the right side. So according to the given position and velocity values, it just sees that which action will be the most optimal, or let's say if this 1.8 and 0.6. So since this is the most rewarding one, it will choose this. So initially what will happen is it won't have enough speed to just go here. So for this current position and velocity where it's right now, like initially the position is, let's say P3 and the velocity is 0 initially. So what it will need to do is it will need to go to the left side so that when it comes down, it will gain a bit of speed, and that speed will be sufficient enough to get it to this flag. So this is done by, it will just look up to the table. Let's say the initial position is P3, let's say, and 0. So in the table, it will be like for this current one, the left is the most rewarding action. So the car will come here. And then for this one, right side will be the most rewarding one. So it will take that accordingly. So Yes, so the training is done, and these are the reward results. So according to the for this, I think was around 3,000, around 3 something, if I'm not wrong. So from 3,000, we can see the rewards are like because once we get exactly how to get to the top of it. So it is according to that. So now I'll just run this. So and then move to tools so that we get the visualization of it as well. So as we can see now, it goes to the left to reach the speed. Yeah, so I was talking about this graph. So what I did here is in the mountain car example, I set the epsilon decay rate to 2 divided by the number of episodes. And in this case, I'm training it for 5,000 iterations. So 2 divided by 5,000, it should be around somewhere for 4,000 episodes. So yeah, around at 4,000 episodes, as we can see, the rewards are pretty high and they're getting constant because it has been trained, and once the epsilon is decayed and it has come to 0, now it doesn't take random actions. It will just take the most optimum action. So the reward is high and constant after 4,000 iterations. So if we see the simulation for it, this is the simulation. So the car starts here, it gains some speed, it reaches the flag, and then the game will just restart. So it goes to left, gains the speed, and it reaches the flag. So this keeps on going. And apart from that, this is what I could understand from the engine library for learning. And this is that's me. So actually in this, the average reward, it's just constant. That as you can see, it's just stuck 50. The problem with, I think, this is happening to plugin that's available. So what I was saying is this was Himanshu's last year's NetLogo model. So actually the problem in this is the reward is staying constant throughout all iterations. I think the reason for that is he utilized the Q-learning extension that was there in NetLogo. But the issue with that is, like, once you, let's say you train it for 10,000 episodes, so the trained data, it's not saved anywhere in NetLogo. So it just vanishes after the current session is closed, or if you close NetLogo, it just vanishes. That's why the rewards like always stay constant. It's very static, it's not dynamic. So in this case, I got to know about this. There is a library called Pickle in Python. So what this does is, here I'm initializing my Q table, but then after the training is done, I'm just dumping this into a .pkl file, which is some sort of binary file. So it just always saves the Q table in the form of a binary stream, or I think it's a character stream. And then whenever you run your model again, it is just utilizing that. So the more you train, the more efficient your agent becomes. But I think that is not really well established in the NetLogo's Q-learning plugin. So I think doing that in Python will maybe help to solve that problem as well. So this was Himanshu's model. And so what I was thinking is, I can, like, in Mesa, so basically there is an option to build a grid environment. So I was thinking that maybe if I can build a grid, something like this in Mesa. So let's say that we want to consider a case. Now this model Himanshu built, it was just for that, let's say there is a contributor in an open source organization. So the contributor can be promoted to, let's say, an admin or a maintainer of that project or of that community. So this is what this model was all about. So what I was thinking is, let's say we can have the contributor start from this place. So here is the contributor. And then he has these 4 actions that he can take: up, down, left, and right. And at every coordinate, we can set something like, maybe this coordinate has a level 1 issue that has to be solved. This coordinate, let's say, has a level 3 issue, like complexity level of an issue that is to be solved. So let's say after he solves like 5 complex issues, let's say if a contributor is able to solve 5 complex issues, then he can be promoted to an admin or maintainer. So when he does that, he can maybe reach this endpoint. And the coordinates, like let's say at what coordinates, what reward we need to assign, that can be made by this Q table. that we are maintaining through the PKL file. So this was the basic idea I'm getting till now. Apart from that, I also worked a bit on the documentation, but there are some minor changes to be made. So I'll share it in the Slack by tomorrow.
Yeah, that's great. I'm writing some notes here. So yeah, that's great. Thank you for the presentation. Any questions from anyone? I have some questions, but I'll let other people take any if they want to first. Okay. So yeah, I like the application of Q learning and like kind of the breakdown of what Q learning does, and the idea that you can have like I guess in NetLogo you can't save your training from session to session, so you just have a refreshed training table. You have to reacquire the data and everything, and it's part of it's an artifact of like the platform, but also of like the way that they're doing it as a agent-based model. Basically, you want to start the simulation new every time, which is fine if you're wanting to like demonstrate the procedure, but if you're trying to use it for like something else, then it's kind of difficult to. So I appreciate this sort of like working on this table and trying to figure out a different approach to it. I like the way you've mapped kind of the problem to the Q learning. So it's like you have to acquire certain competencies and then you learn from like a space of possibilities what the optimal strategies are. So that's nice, yeah.
I also looked into like Jim has a section in its documentation where you can make a custom environment for yourself using the OpenAI Jim, but that wasn't looking like very feasible to me because it's a bit restrictive on the way, whereas Misa is a bit more. I would say it's a bit more minimal and lot of customizations can be done. So I think extending on Misa would be still a better option. I tried to make some environments in OpenAI Gym, but I don't think it would be very good for the long term. Right. So I think I'll make the environment in Misa itself, and then I have to somehow incorporate the Q learning inside Misa. So the idea for that I had is like if there is a grid in Misa, then the coordinates like let's say there is a coordinate 1, 1. So the reward at the coordinate 1, 1 can maybe be stored in the Q table and the movement of the agents can be made accordingly. I still need to see, I still need to figure out a way how that should be done, but I think I can do it.
Yeah, I think that's great. All right, yeah. And so your timeline for this is to get this implemented. You think? I mean, how long do you think it'll take you to implement something?
I think around. I think I can try to get the demo, like the basic demo, done in maybe 1 week or 10 days.
Okay, that sounds good. Yeah, so you implement a basic demo, and then that would be a good proof of concept. And then we can see kind of the moving parts put together, and then I think that's great. Any other questions for Raj? I know Amanda said it was a pretty nice demonstration, so yeah. Well, thank you for that. That was very good.
Thank you.
So yeah, Raj has been working on reinforcement. Well, we had a reinforcement learning model from last summer's Google Summer of Code for our open source sustainability initiative, where we're trying to build a simulation of open source activity in an open source community, and then we build upon that and try to understand how to, we can, if someone were to come to this tool that we're trying to build, or this approach that we're trying to put forth, and wanted to, say, predict optimal or sustainable community activity, they could do so. So we have like 3 different ways of doing that. And this is one of them that Himanshu Shobal came up with, which is reinforcement learning. and he was using NetLogo for that. But of course, NetLogo has limitations, and so Raj has been he's been working on this summer to put this together as a to explore the reinforcement learning aspects more. And so this is the result. And so I think this will be mapped to some of the things that Himanshu did last summer. So he was working on the NetLogo simulation. It was a basic reinforcement learning simulation using Q-learning as the reward algorithm. And he was working on this model of different types of achievement. So, you have different tasks, different issues in the community that have different levels of task. So you have like the Earth shot, the Moon shot, and the Mars Jupiter shot activities, and each of those are of sort of greater levels of complexity and of skill. So the idea would be that you would acquire certain skills, or you might acquire a certain set of issues. As you do those, you gain a competency and you can complete the first level, and then you do some more things and you gain some competency and you complete the second level, and so on. So you can complete these kind of tasks of increasing complexity with increasing amounts of competency. So this is, and then of course the algorithm is helping the agent learn the optimal strategies for achieving these. And so that's basically it. And so if you look at the NetLogo simulation from last summer, the way Himanshu had written it, you have these different sort of types of tasks, these certain types of issues that are of different complexity, and then you have sort of agents acquiring certain levels of skill. So they go from like a beginner contributor to a maintainer, and then that of course requires you to have higher levels of skill, and then those individuals are more invested in the community and so forth. So I think this contributes pretty well to that. So yeah, I'm looking forward to seeing your demo, and we're still working on our Google Summer of Code projects. We've both of our students have taken an extension, so that means that their projects are due in October. So we'll be looking forward to seeing the final products in October for that. Looks like Morgan joined us, and then Jesse's Screen has joined us. So welcome, Morgan and Jesse's Screen. And so I don't know if you wanted to give an update, Morgan.
Really happy to be here today as Jesse's Screen. So good to see everybody.
Yeah. Well, Morgan, you can put an update in the chat if you want. So I guess we can move on. If Jesse wants, I take it you're planning to do a presentation or an update of some kind?
Actually, I'm not. I'm just navigating through the city streets, and so I may leave when I get back, but I'll be kind of busy for the next 10 minutes or so.
Okay. So yeah, why don't we move on to some other things? So I usually go over the Slack a bit in the meetings, and we have so many things going on in the Slack, it's hard to keep track of everything. And so I'll go through some things in the Slack that are pretty interesting recent things. So the first thing is we have, of course, our Braitenberg Vehicles channel. And one of the things that Raj had talked about in his presentation is that we're using AI Gym. And so that's something that we were trying to do last year, trying to implement that. But I'm glad to see that he was able to get that working on a problem. And, my idea for that was that we could use that not only for this project, open source sustainability and these agents, but also for training different types of agents that we use in the lab more generally. So one of the things we work on these developmental Braitenberg vehicles, and so this is the channel for Braitenberg Vehicles. And it'd be kind of interesting to throw some of our developmental Braitenberg vehicles into there, see what we could do in terms of training those kind of models, those kind of autonomous agents. So in this channel, we also post readings on things related to agent learning and things like that. So this Morgan has been posting a couple things in here. Morgan posted this article on a perspective on large-scale simulation as an enabler for novel biorobotics applications. So one of the things we're interested in with Braitenberg Vehicles is the developmental aspects of learning and of sort of agent or computational agent morphogenesis. So, we're interested in these biorobotic or bio-inspired applications. This is interesting. This is a perspective on large-scale simulation as an enabler. So this is from Frontiers in Robotic AI or Robots in AI. And this is kind of an interesting way that they, people have been trying to make these kind of analogies for many years, and there have been many, many papers on this. So it's, it's always kind of like, I see this interesting thing in biology, I want to apply it to a robotic context. Let's see what it looks like. So let's see, what does the abstract say here? Our understanding of the complex mechanisms that power biological intelligence. So there's biological intelligence, and that of course is distinct from artificial intelligence, but you have to define intelligence, but that's the idea. Has been greatly enhanced through the explosive growth of large-scale neuroscience and robotic simulation tools. So, we're looking towards neuroscience as inspiration, but again, we have to kind of figure out what elements of the nervous system we want to use to simulate that thing. And then we have robotic simulation tools. So one of the great things about using with computational agents, especially with things like Braitenberg Vehicles, is that we have a computational model that we can implement in a robot. And we can simulate a robot in, with tools like this. So, these are experiments that in a lot of cases are infeasible if you use an animal model, or if you use kind of a standard robot where you have, like a Kepler robot, which is this little circular robot that they've used, very, very classic model of a experimental robot. So, you can actually use these kind of tools to get at questions that we haven't been able to get at before. Some of these include the simulation of neocortical circuitry. So, simulating neocortical circuitry is one of the main areas of this sort of biorobotics field, because it's thought that, especially human neocortex, neocortex is just basically 6-layered cortex in the frontal lobe of mammals that does a lot of cool stuff related to cognition. So the thinking is if you simulate this, especially just kind of like mimicking the human case, that you'll end up with really complex, intelligent behavior. Now, whether that assumption is warranted, I don't know. That's what people have been working on. So this is where there's a great interest in this, and maybe that's the wrong path, but that's that's for history to judge, I guess. Nevertheless, simulation falls far from being directly applicable to biorobots due to the large discrepancy between the simulated and real world. So one solution to this problem is enhancing our tools for simulating robots and their actions and the nervous system that's generating these actions. And they propose this multiphysics approach. So what that does is allows you to model different aspects of the physics of the tasks. And so it's very much like what we talk about with embodiment. So why is embodiment important? Because it allows the body of the agent to interact with the environment, to interact with the nervous system that's generating the behavior. And if you have multiphysics, you can do things with that interface of the environment that are very quantitative. And so then you can actually trace the influence of the environment through these physical parameters into the nervous system simulation, and then out towards the behavior, which then does something in the environment, has an effect in the environment. So if you think about swimming, when you're swimming, you're putting your hands through the water. The water has a resistance, and you push against that resistance with your muscle. You generate muscle activity, you generate muscle power to match the impedance of the medium that you're in. So the robot has to do this in their peripheral nervous system, and then in the central nervous system, that gets integrated with visual cues or haptic cues of the water and of the position of the agent. And then but those are different physical parameters that we can simulate and see what the effect is on the nervous system of the agent. So this is why we're interested in multiphysics simulation. And so this if you want to look at robots swimming on the water surface, interacting with soft materials, walking on granular materials, this is a good approach to take because you can simulate a lot of those interactions with the environment and quantify them and then use that as an input to the nervous system. So it's easier to operate on numbers than just simply saying that there's this switch in the environment and a switch in the physics of the environment and that has an effect. So in combination with multiphysics, large-scale simulation tools that integrate multiple simulation modules in a closed-loop manner help address fundamental questions around the organization of neural circuits and the interplay between brain, body, and environment. So that's what we were just talking about. So they propose a next-gen modular architecture design based on multiphysics engines that would benefit both biorobotics and AI more generally. So that's a really nice paper. So that's kind of the direction in which some of this stuff is headed. I think it's definitely a good sort of way to think about embodiment and some of these other issues like embeddedness and other types of things. The multiphysics aspect, multiphysics is a really hard problem. We've been talking about multiphysics kind of off and on in the DevoWorm group, where we're trying to simulate the multiphysics of cells and development. And so it's a very similar problem because the cells are in this medium and they grow and they migrate and they form tissues and other things. And so, they're building, these very ultra-stable structures sometimes to resist some of these environmental pressures. And then how do they make these configurations? And so it's a similar problem, but it doesn't assume any sort of really complex intelligent behavior. It just assumes like different types of responses of the cell to these stimuli from the environment. So that's very interesting work. The other thing I found really interesting is this stuff. So this is this GitHub repository, which has, and there's an archive paper associated with it. It's something called PointLM Empower, empowering large language models to understand point clouds. So we know large language models as being sort of like this thing, you give it some textual data, you give it text with words, with, strings and characters within strings, and it can actually put together sentences and, maybe they make sense, maybe they don't. People have been innovating with large language models as these sort of generative models. And in this case, what they're doing is they're using it to understand point clouds. So this is where you have these different objects and, there's point clouds, there may be objects, maybe not. And you have to be able to understand what you're looking at. So a lot of times when we have data, we have this point of data points or this cloud of data points, and we have to do something with it to understand it or to analyze it. So you might put a regression line through it. You might try to cluster it. You do these other things. And then we interpret that as like, there's structure in the data, there are clusters or unified groups. There's, a trend of some type between two variables. This is where using a little bit different approach. This is where you have this object and you're asking questions about it. And it's like this inquiry where, you have this agent that asks about this point cloud that looks like a shoe. Why do people need this thing? This is a shoe designed for athletic activities. Let me zoom in here. You can see the text a little bit better. Okay, this is a shoe designed for athletic activities. It is designed to provide support, comfort, and improved performance during sports or exercise routines. What color is the inside? Is the shoe meant for the right foot or the left foot? Then the other agent says the inside of the shoe is orange. It's meant for the right foot. So this is like a right shoe, and you're kind of giving information about it. So it's basically you see an object, or the agent sees an object. It's a point cloud, so it doesn't know what it is. There's no label. It doesn't have any a priori model of what it is. And then it asks questions about it. And then the agent, which knows what it is, gives answers. So it's driven by inquiry. So it's basically doing like science. It's asking questions about the data, but it's asking in terms of a point cloud. So you have objects. These objects are, real objects. We know what the labels are. We know what they are. But we just use it as point clouds. So the point clouds are individual points that put together a pattern. And then you ask questions about that pattern, much as like if I had a point cloud of like an elephant, there's this famous saying that like, I think it was von Neumann who said, with 4 parameters, I can draw an elephant with a tail, and then with 5 parameters, I can make the tail wiggle, or the trunk, I guess, trunk wiggle. And so that's what you're trying to do here. You're trying to build a point cloud from free parameters. They have these different shapes, and then because we can actually label these shapes if they make the thing that we desire, like a car or a dinosaur, then we know what that is. And then we can have like a database of answers for questions. So if I ask what this is, or if it's a car, I know it's a car, but I don't know what kind of car it is, then I have a starting point to ask questions about it, and the agent can answer them. So that's kind of an interesting way to do it. They have a Gradio demo, and they have an archive paper. So this is, if you want to try this, it's online. There are different dialogue examples you can get. And then this is the way it works. So you have the large language model, you have these text tokens here. You have ignored tokens, so it doesn't take every token. You have the tokenizer, the projector, so you have this point cloud that comes up. There's this point encoder, so it takes an object, it encodes it into a bunch of points, then it projects it into this latent space. There's a tokenizer, and then that input, that serves as an input to the large language model. And then there's an output of text tokens, and that's how it works. And so you have this ground truth step where you know what the object is. You have then you have questions that you can ask, and then you get this dialogue that happens. So we had something in the chat, I think. My Little Pony, yeah, that was Hussain. Yeah, so that's Braitenberg Vehicles. There's some really interesting stuff going on there. We haven't been talking about that as much recently because we haven't had any active projects, but I will remind people that we do have open source code in some of our development of Braitenberg Vehicle projects. It's been a few years since we've really focused on that, but I would like to maybe get back to that. Cognition Futures has also been very active. We've had a number of things here. Amanda found this book, Thinking in Systems, which is a nice book on dynamical systems theory and its foundations. We've had some other readings so we have a separate group on Wednesdays, which is the Cognition Futures group. And we do, it's a reading group, we do different papers, we do different books. We spent a very long time on the Fuchs book, which was on phenomenology, and this is an interesting book. We've been doing more readings on different papers more recently. It's really like philosophy, but also, embodied cognition and things like that. So you'll get, a nice overview of some of the stuff if you attend our meetings or, follow our discussions here. So yeah, we have a couple of papers here. Amanda's posted a couple of things here. And I found this paper, A Theory of Intelligences, Concepts, Models, and Implications. And so this talks about intelligence and sort of a theory of intelligences. So there's a debate as to what intelligence actually means. And so this kind of goes into that. It's a take that someone made on this. So yeah, that's good. Nothing really going on in cybernetics, although I hope that we can revisit this a little bit more. We were talking earlier about some of the things that, we might do in the area of cybernetics. And, we've been working on this Human Use of Human Beings book. This is by Norbert Weiner. And he's been, this is a book of historical interest because he links a lot of like what was going on in the cybernetics movement of the 50s and 60s with like the society of the time. And it has a lot of implications for like modern technology and, modern sort of thinking about the world. So this is this is something we want to kind of drive forward. This is something we haven't talked about in a couple of years, but we're interested in revisiting it. So I don't think we have anything in the Virtual Reality-Neurotech channel. Well, actually, we do. We have a couple things. Morgan and Hussain have been contributing here. Hussain found this thing on surgery using augmented reality. This is Meetavis, which is harnessing AR and computer vision to build technology that helps improve surgical care.
Right, would you like me to just comment a bit?
Oh yeah, go ahead.
Yeah, thank you, Bradley. And excuse me for interrupting. So this is, I was just looking for what was readily available for scientists and doctors in their way of using augmented reality, in their way of using AR. That company in particular, they're really taking off. So I was just networking and seeing what sort of opportunities were available. So yeah, within the XR communities that I've been part of for virtual and augmented reality, people really come in with extremely diverse backgrounds, and it's really crazy. Like we have scientists, doctors, journalists, like people who work in like sales and so many different things. It's hard to think of a field where AR just isn't really going to be relevant with anything, really, in some ways. But yeah, for that company in particular, for Meetavis, they it is really just taking a lot of stuff that a lot of knowledge and ways of a lot of knowledge and research or some scientific and medical perspectives, and just asking yourself, how can you do these same sort of things but using AR? And that's what makes it so practical and applicable in many ways. They're not like, say, reinventing the wheel or trying to they're just building off of what's already very easily available and what can provide very practical things to physicians when they're performing surgery. So
Yeah, I think that's a good question. Like when people build, or people actually ask about the utility of like XR, VR, AR, and that sort of thing. It's like, we can do things, usually the answer is we can do things like differently, or we have, there's some value in simulating things, but it's really kind of like a lot of it is like these proof of concept things where you have like this demo and then, the demo works and then, but it's not clear like what the applicability is outside of that. Are there use cases that people will really use it for, every time, or is it for training, or what? Yeah.
I mean, because the surgeons themselves, they're highly trained, highly qualified people, and they have to do some really well thought out things. But really, like it's all dependent on the scientists and technologists making things available for them these ways. So for Meetavis in particular, it's just for Meetavis in particular, the intersection of AR and AI too, just provides some really great ways of optimizing these procedures themselves, like being able to really visualize, say, what sort of reconstruction you might need within a musculoskeletal system, or these parts of like the brain or things like that, and it's all there. So
yeah,
whatever can make life easier for doctors.
yeah. Yeah.
Yeah.
I find that area kind of interesting, the AR AI kind of interface or the VR AI interface. So, like, you have these applications and you say, well, I can use them in a certain way. And then you're putting AI on top of that. And so I guess it's optimizing things, right? Like, or what have you seen in terms of like AI applications that you found really exciting with respect to XR? How does it make it better?
Just with anything you can do, basically. Like, you seen like at Niantic, they developed or excuse me, at Eighth Wall, which is owned by Niantic. They've been developing artistic sort of projects and creative projects where you can just type something in a command prompt and like a mushroom, and it'll generate a mushroom for you and be able to see the image there. Maybe you have to draw it like a little bit, but as long as you can describe something, it'll be there. But it's like the biggest thing is with things like object recognition, spatial recognition, voice and video recognition, being able to even perform predictions on what you might need to be able to do or where things might need to be able to go with like let's say you're like consulting with a physician and you need to visualize something, like a physician or a surgeon is trying to visualize something right in front of them while they're performing surgery. So being able to predict what the outcome of different procedures might be, I could definitely see that having a lot of potential. So
Yeah, that's great. Yeah, just it's always a game of like we're building demos versus like we're using this in a wide variety of contexts. If you think about like your average computer application, like Word or a web browser, those are things that are pretty diverse. People use them for all sorts of things. And so, like with a lot of XR, you have these sort of demos that do a certain thing, and then that's it. And then the challenge is to make that broader, so that you can have something you can use in a wide variety of contexts. Sometimes you might not because it's just kind of like a phone app where it might do a very specific thing, but other times it might be like what you're saying, where you can plan things out, or you can do things like a reinforcement learning optimization, where you're optimizing for a bunch of things and trying to figure out different options and then visualizing them. So I can simulate a scenario. I could simulate like a building being there or some surgical step or whatever it is. So yeah, it's great.
yeah, and I shared another article there too, just another one there.
Okay.
Let me imagine that for you, transforming the retail frontline. Yeah, with advertisements and with sales, it's just becoming really like using AR to process what sort of decisions, what sort of choices a consumer might make in a retail store, like what they might be looking for, what they might be trying to do. It's yeah, that was making rounds on LinkedIn when I was talking to people. So yeah, it's something people see as definitely a boon, but also in some ways, it could come with potential like flaws or disadvantages. People are being very very careful with augmented reality. That we could just imagine a world where when you're walking outside, going to a store, doing something anywhere, you're going to just be absolutely flooded with images to view on your phone with like augmented reality advertisements, and things are going to be everywhere, and it's going to just overwhelm people. So people are trying to be careful and cautious about what the future might look like and the best ways to regulate those things too. So
Yeah, I think that's yeah, it's always a challenge with regulation and having new technologies coming in. It's always something we have to think about in different ways.
I think that's something that is quite interesting. Like I mentioned recently, different portrayals of the future, different video games. Like one of them is Cyberpunk 2077.
Yeah.
And I was thinking about that because I've talked about it in the past a little bit in terms of like it's an immersive environment in the city like landscape. But I feel like that's one thing that a stark contrast in that portrayal of the universe because a lot of the things we talk about in a lab, and like we're talking about like the brain dance feature, which is this like totally immersive. It's basically part of the shared cognitive environment stuff and all these other things, and all like the magical technology that exists in that space. But I particularly noticed what was just said, like there totally, in that universe, there totally could be oppressive augmented reality, just generated things, or even like the way they do cyber, where like just heavily pushed advertisements in that world, and it's not. Like even I noticed it because are there billboards everywhere in Night City? Yes. And even like on the in like the highway spaces, there's just these like very tall, almost like palm tree looking things with sort of rotating billboard signs on the top, but there's nothing really in the face about it. And I feel like that's very much an aesthetic choice for how to portray the cyberpunk future, even though it's inherently cyberpunk in that it's inherently, for those who aren't familiar, like the point of cyberpunk is that technology as a genre or as a theme, like is that technology doesn't sterilize and make pristine all human situations, is that there's still the ugliness about it. But I thought it was kind of interesting because even in that context, there's still a little, in a very gritty world, there's still the sort of, they go pretty gentle on the advertisement space. And I really wonder, I'm saying that in part because I think that's actually, I think that'll be a major, it already is, like there's already the attention, push an attention economy and all this stuff for that. But like as we move towards these spaces that are, as one person calls like the substrate monopoly happens, as you're more and more and more, your reality is put through the loop of someone else, and like someone has the control over it, or there's like you're jacked in, and you can go full matrix for that, or just like as someone is connected constantly to stuff. Right now it's not. Most right now it's in your hand and on a laptop screen. It's not it's not entirely part of you, and so the Cyberpunk 2077 game, the technology is inside you, and the displays are in you, or at least in the portrayal of the first person game. But we're not there yet, so I feel like as that will be a really interesting like arena as we move forward to see as the technology as you're more hardwired, if you will, towards the technologies, wireless or not, as they're more and more a part of you, how does that shift? Because is it I could see it being like in the future, like, oh, like there's just to kind of combine a little bit we talked about, a little bit of cyberpunk and what Hussain said, like what if there was just like a constant banner on the like bottom 5% of your field of vision at all times that was an advertisement? Like I feel like that's not far away at all in terms of happening if you were in that environment. It's basically just like being on certain websites right now. I'm not really, I don't want to go too far to that. That's kind of an allusion to some stuff that I would be really interested in discussing, like a society ethics tech thing, but also a little bit of an allusion to one of the things I wanted to mention, and I don't know if we want to do a full segue yet, but just to do a teaser, we're almost at We Robot time, so I'm starting to finish up some things with that. But We Robot is on the way, and that will I'm sure that's going to come up there. What I talked about, these sort of We Robot, for those that don't know, is sort of this law and technology. But what basically law is basically all of society, and robots are basically all of technology and AI. So it's not just about robots; it's about this sort of interface. Okay, Raj, thanks. It was good to see your stuff today. So that's coming up soon, and I didn't forget about it because I'm doing things there, but I forgot that I can be excited about it because there's so much stuff going on. But I feel like what I'm talking about now will come up there. It basically did last year, like the what are the boundaries of that. So it'll be a really fun event that we are plot twisters should be at, and I'm attempting to do kind of a frontier map chat GTP presentation of sorts there too, poster. So that's on the radar. But I don't know. We don't have to go fully into discussing this right now. I don't want to break things up too much, but I did want to kind of take the natural segue to mention what things are on the radar for us.
Okay. I'm going to present something real quick, and then we can go back to that for a bit, and then I have something else. So can we do that?
Yep.
So we'll come back to that in a minute. So one thing, we're segueing from the Virtual Reality-Neurotech channel. So this is actually, a lot of this is sort of very application-oriented, as you can see some of the things we've gotten in the channel. We have this, how artificial intelligence gave a paralyzed woman her voice back. Some other things here. World's first virtual reality study aid. This is Shapes XR raising funding to expand its platform. Now we have a Discord that has more like sort of more conceptual stuff, sort of things that aren't like linked to applications so much, although we have some of that. We have the Discord server for that, and I've been adding to that on a regular basis. So, we have I'm not going to talk about that today though. So one of the things I've been kind of interested in with respect to, and this is again one of these more conceptual things that I've been kind of interested in, is building hyperbolic spaces or non-Euclidean spaces in VR. So this is an example of a non-Euclidean space. So it's basically a space where you can navigate through, and it has this sort of constant positive or negative curvature. So it's very different from navigating a Euclidean space where there are right angles and things like that. You go through the space and you're always following a curvature, and it's kind of hard to get used to at first because it's not like the world we live in. And so there are a number of YouTube videos where they do these like animations of hyperbolic space, and you're navigating through a corridor, and you can sort of guide your way through there, and it's very disconcerting at first, but you get the hang of it. But it's a very different set of like spatial navigation skills than something like, say, navigating a maze that's Euclidean. So you have different landmarks, you have different ways to follow the space. It's actually a wonderful environment for looking at ecological psychology and visual optic flow and things like that, because the cues are very different from what you experience in the real world. So, a lot of times we'll have VR simulations of like, a maze, and it'll be sort of hyper realistic, meaning it's exactly like what you would see in a maze in like the real world. But in a hyperbolic space, it's not like the real world at all. In fact, the challenge is to map your knowledge of navigation in like a Euclidean space to a non-Euclidean space. There's an application for the Meta Quest, which is Hyperbolica. This is something where you can build non-Euclidean spaces that are more sort of like landscapes or objects. The videos on YouTube that I can point to are just like these three-dimensional spaces. Are very abstract, but you navigate them, like a maze, and it's like very disconcerting. And you can view them immersively, so you can pull up like your YouTube app in the Meta Quest, and you can like open it up to VR standard, so it's like full screen. You're immersed in that space, and you can kind of learn to navigate along there. It's kind of hard, but this actually allows you to build worlds that are hyperbolic in this hyperbolic mapping. So that's kind of interesting stuff. There's this paper actually that kind of talks about the sort of Physics and Mathematics of Hyperbolic Spaces in Virtual Reality. So this paper is it's from the archive. It's in one of the maths repositories, and this is Non-Euclidean Virtual Reality 1, Explorations of H3. So this is a group of people working LEVR, in someone in the School of Physics at Georgia Institute of Technology, and a mathematician. So they're working on this. This is a view from H3. This is a hyperbolic space. It has these shapes embedded in it. So it's very different from a Euclidean space. So they've been doing these initial explorations and simulating non-Euclidean geometries in virtual reality. Again, we know non-Euclidean geometries from mathematical descriptions. People have simulated them in like 3 dimensions or higher dimensions even, although it's harder to visualize anything more than like say 4 dimensions. But still, our simulations of 3-dimensional hyperbolic space are available at h3.hypernom.com. So this is a website where you can find more about these 3-dimensional hyperbolic spaces. And so really it's just about simulating them, presenting that simulation, rendering that simulation as something you can interact with, and then having it in an immersive environment, like in a headset, and then having it where maybe you're in the space trying to navigate and then learn that navigation strategies, which are going to be fundamentally different from the navigation strategies we use in Euclidean space. What's interesting is that in spatial cognition literature, they hypothesize these things, these constructs, like grid cells and place cells and things like that, and those sort of representations sort of assume Euclidean space. Grid cells in particular sort of have an assumption of Euclidean space. In other words, if I have a rat and it's navigating its way through a cage or through a maze, it has to use landmarks that are Euclidean in nature. So there's a spatial grid that's inferred there with place cells and landmarks that you basically tie together. So the rat moves from landmark to landmark, and that's like there's a space in between that's inferred, and that space is Euclidean. In a non-Euclidean space, you might have landmarks, but those landmarks don't have the same relation to them. They have a curvature, and so then you have to learn the curvature. So it's a challenge to what we know about spatial cognition, I think. So if we can implement these environments and train people on them, or even train like an animal model, like a mouse or a rat on them, then we could really learn some new things about spatial cognition. So they talk about these surfaces in the topological sense. They don't come with a particular choice of geometry. That is, we can think about a surface as if they were made from plasticine without knowing what lengths and angles mean on the surface. So you can make this simulation and have a framework and then generate new geometry. You can generate new topologies. The geometry, it's not, you don't have to specify the geometry. It's best to just kind of generate them from different properties of the topology that you want. And so, so there are, however, particularly nice geometries for these surfaces. Isotropic geometries, meaning that the geometry is the same everywhere in the space, facing in every direction. We have spherical geometry for the sphere, Euclidean geometry for the torus, and hyperbolic geometry for all the others. So again, this is different from a sphere. It's different from like a Euclidean sort of torus. It's like a torus is like a donut. That's something that we have a strong familiarity with as humans, as the kind of biological intelligence is built from interacting with these kind of spaces. Hyperbolic geometry, however, is not intuitive to biological cognition, at least as far as I know. There might be some organisms that use hyperbolic geometries like representations, or maybe they interact with hyperbolic geometries, maybe at very small scales in nature, but we don't know that. In 3 dimensions, the story is more complicated. So they give some mathematical background here about how these spaces differ from three-dimensional Euclidean spaces, and this is a three torus, which is like a grid in 3 dimensions in Euclidean space. So you can see the linearity there of the squares and the cubes, and this is a skeleton of a bunch of cubes. This is the 3 torus, gives us the 4-3-4 honeycomb. It's just the mathematical notation for this space. And then these are screenshots from Curved Spaces by Jeff Weeks. So these are a bunch of simulations. This is the Euclidean space. This is the 5-3-4 honeycomb, it's almost like its counterpart in this non-Euclidean space. And so you can see it's very different because you have you have a different set of shapes. You have a different set of interactions. You can see a visual scaling that's very different. And so it's very hard to intuit how to navigate this or how to map this to this. It's extremely hard. So I'm not going to go much further into that. I just wanted to talk about that. And yeah, I think it follows up on something that I'm interested in. I mean, I don't really have much more to say about it than that at this point. So we have, let's see, Jesse, well, thank you, Raj, for your presentation and coming today. Jesse said, is there in this paper or elsewhere discussion about how non-Euclidean spaces reflect different environmental laws or properties at hand? Which an example would be having influence on the space formation or navigating it. Yeah, that's something though in the literature I don't think people talk about too much. I just mentioned that about like spatial navigation because it's an obvious thing that you would think of. If you're in a space and interacting with it, you have to have some model or some representation for it, or at least develop it if you do enough of this. And we don't get experience with it in the real world. We get experience with Euclidean spaces. So if you train someone in a non-Euclidean space, what would it be like? Do they develop a new representation, or do they co-opt old representations, or do they even need a representation? Do they just kind of learn the space and the flows and everything like Gibson would sort of posit?
Can you say that last thing? I say that about Gibson, and then you said something, and I couldn't hear it.
Oh,
that
that if we build a representation of that non-Euclidean space, or we sort of build out upon we extend our Euclidean representations, or if, like Gibson would argue, we don't really have representations for it, we just follow the visual cues or the visual flow. And the flow being different, we just learn that as different information. So it's like that's how we might interact, right?
I think, and I say this with a little bit of knowledge of some of your past interest in VR and the scaling differences and the different perspectives and the different size and like that stuff. I think between that and a lot of things that came up today and things like Hussain has mentioned otherwise, I think there's something there I would like to look at too, because I think going back to the methods project of the Cognition Futures methods project, which is kind of a major area of interest, I guess, for me and stuff we're doing is I think that's an actual methodological opportunity to sort out some things, but maybe even like to, I don't know, zoom out or step a certain, I don't know, whatever directions just adjacent to that comment. I would say I think there is a lot there in order to what was just said, as there's sort of developmental implications for that. Also I wanted to say, yes, how do I say this? The interesting thing is that there are implications, and I think this is a hypothesis speculation about such. Why I mentioned that, and why I'm glad you mentioned GSoC information, is that, so we've kind of talked a little bit in the past in the lab about like computation and the nature of shifting between states. And I feel like I'm not really, I think it's a bit of a stretch to say, oh, well, let's all, we're all going to be navigating non-Euclidean spaces real soon, and we're going to learn so much that way. No, but more like, I think what looking into that arena might interestingly get at is when we look at a situation, and I don't know how Gibsonian information really gets into this, because this is very much of my own thoughts, I guess, or like I would really love to explore deeper into. I don't know if it's fair to say Gibsonian information or not, but when we look at information or look at like a visual scene, there's a lot of latent or indirect information too, and assumptions that are there. There's a lot of you're not really wondering. You can wager very heavily based off your experience that you're going to maintain being in a non-Euclidean space, if that makes sense. Like you don't have to constantly scan the workings of their reality all the time to see, wait a second, do Euclidean rules apply or not? Obviously you don't think that, but like there's sort of, I think that's one of the things that's sort of a layer of implicit, like there's been I think it's a really hard thing to understand developmentally, like straight up developmental biology, like the cognitive stuff. I think that's a really interesting, like we talk about this a lot of times with like the genomic bottleneck, or Saffron's take on the physical bottleneck. Like you don't have to consciously choose not to extend your legs beyond 270 degrees. Like I don't have to go 270 degrees in this direction, because your legs only go so far. You're gonna have to limit it. Like some limiters are built in that way. But I think there's also similar like heuristics, if you will, or limiters on those other things too, that are reinforced by these things that we're talking about too. Like you don't have to shift in and out of awareness of non-Euclidean space. Similarly, I think there are developmental, like when you're balancing, when you're dealing, as your anatomy develops, as your brain subcomponents develop alongside your rest of your physical anatomy, there's stuff that doesn't, like from a like evolutionary efficiency, energy conservation, minimizing expenditure sense, there's stuff that just doesn't. It's so much cheaper to just not account for it and develop in these particular ways, and I feel like that's hugely related to all of this too. So I'm digressing a little bit, but and I will say, did you want to say more about this, or are we ready to shift to other things? Because there's a lot of segue points here.
Yeah, I think we can shift to what you wanted to do with the administrative stuff. So this is just food for thought for later. I'm sure there's much more to say about it, and we might talk about it in future meetings. But
okay,
yeah,
yeah. There's a lot. There's a lot here. There is. I will cover the administrative stuff shortly. The most immediate segue would be there's some interesting things I'm churning up, and I don't know if I'll be able to share anything about it or like show image or whatever, because there's been a bunch of different books, but there's a relationship to what I'm saying to like I've been getting a little bit into like Karl Popper and his take on history of science and his take on theories and stuff like that. And the big thing for him is the falsification, whatnot, and how the goal of science is just to relentlessly throw critiques and try to disprove theories, and then, like that's sort of what you do. And I don't, I'm not a Popperian necessarily. I'm just learning of what his issues have been, and a little bit of context about how he came about. Like it's interesting to see his own like actual. I found one of the most interesting things of one of the books on him is like just describing how he came through early 1900s he dealt with Marxism and psychoanalytic and stuff, and he dealt with Einstein and his theory of relativity and the photon stuff, and how Einstein was had his theory, but was also like really open to it being challenged, whereas he saw some like political or religious dogmas as being, well, we just want to find things that confirm us. And he also like mentioned like resistance and psychoanalysis, which is sort of this maximum confirmation, not even bias, but just like you can say, oh well, you're resisting what I'm saying, so that means I'm right, and you can't understand what I'm saying, so that also means that I'm right, and just stuff. These different things that sort of shaped that as he was developing, and how that went on his own views of the falsification stuff.
That's what much of psychoanalysis is based in denial, the defense mechanism of denial.
Yeah,
as it's gathered around there.
And it's interesting because like he's what he's moving towards is getting out this sort of the relationship he has between theories and what theories can do was interesting. So there's more about that, but I'm a little distracted by there's the direction I was going to go with this, but I think it'll be easier not to do it right now. So yeah, we can come back to the admin stuff. What else did you want to actually discuss today, Bradley? I think any of the papers and the things you wanted to talk about.
Yeah, I'll probably do some papers later, but you can probably spend about 20 minutes on this.
Yeah, thanks. I put some of Raj's stuff here, and Amanda has some stuff here. I guess Amanda put these cybernetics and Varela stuff, which is good. I just wanted to recapture this here in terms of Google Summer Code's happening, the Beacon stuff. Is there anything? I know we kind of had I guess that's just still in the works for Bika. What about this one? Are we waiting on this? This is from last year, the EI last year.
Yes.
Are we doing anything with that, or?
So we have two things. The proceedings are forthcoming. We don't need to do anything for that. We're just waiting for it. But then this year we have submissions for. I think they're due October 31st. That's a different entry, I think, in this table.
That's from this year's submission. Yeah.
So the proceedings 2022 is just basically until it's actually published, but I don't think there's any action item there. It's just like waiting for it, and then we will probably want to like advertise it too, because we like to get people to pay attention to it. I would definitely like get it on social media, maybe put a post on the Medium and so forth. So yeah, I would. But then 2023, I don't know. We talked about maybe some of the submissions we might make for that. I've been thinking about it. I'm not really sure what the submission is going to look like. I know Amanda said she might submit her work on neurophenomenology, which I think I encourage her to do. And then that's in the papers usually like. I think there's like I don't know if they have if they've sent out a email on the what the minimum standard is. I don't think there's a maximum standard, but it's usually at least 6 to 8 pages. I think in philosophy you're just going to have by default a larger paper, so that's probably not a problem. But something that's paperish, having references and a structure, and just something that can be followed up on from the conference. A lot of times, like the last couple of years, we've submitted things that we haven't actually presented at the conference, which is interesting because it's like, but that's fine. But yeah, it should be a paper, so we'll probably have hopefully 2 submissions from that. So, and that's due around October 31st, and as we get closer to the deadline, we'll need to make sure that we have the right information about like where to submit it. It's usually through Easy Chair or something, but I'll get the links.
Okay. Let's see what else we have here. So, We Robot, which I mentioned, is coming soon. The ISPSM, working on that. We talked about that. Learning on graphs. I don't know if I think that's going to come to pass. I don't really know.
Well, yeah, we didn't submit a paper for that, so that was. But the conference is still happening in December. We might do something around that. This is more associated Devo worm, but this is more general. If people are interested in graph neural networks, this is a good opportunity to learn about graph neural networks. It's a virtual conference, and you can learn a lot about like the state of the art in that field. So we might do something with that, attending but not presenting on anything right now.
Okay, I don't think we had anything on this.
Yeah, that was preempted by another paper that we submitted. Just got it done this week, and so it's submitted, and I don't know if we need to put that on the list, but hopefully it gets in and we can advertise it. But
yeah, and this one too. This looks like a fun event. I need to put the actual in things for that there. Okay, so I feel like there's been a few things mentioned, but I don't think there's anything else to put on here yet. There's been a few other events and opportunities floating around, but I think this is okay for this part of things. Yeah. Okay. Anything else? There's a bunch of things on my mind, but I don't have a lot to. I don't have a lot more to present on. I guess the only other thing I would say is that it's been quite useful for me to be diving through some of the actual philosophy and history of science work. I think I mentioned last time I found a book on basically a cartographer who also has turned into philosophy of science in history to some extent, and seeing that book is interesting. Reading through some Popper stuff is interesting just to get his own sense of flow and what he's kind of arguing against the way he's using theories. I actually found there was a course, I forget which university, there was a course that was kind of going through introduction to philosophy or history of science, and it mentioned Popper, and we only had there a 9-minute video, but they basically mentioned Popper. They were kind of disagreeing with Popper, so it's kind of funny. I think they trivialized his arguments a little bit, but by saying, oh well, his whole thing was falsification is saying the limitations of falsification and how it's important to have general theories. And I was like, yes, I get that. But I'm curious what evolves in that course and where they go with it. It's been interesting to see different people have this sort of approaches to explaining theory and moving from the benefits and the flaws and the horrors or lack thereof of induction versus deduction, and moving from general theories to specific cases and the way people talk about that. And kind of almost it's almost a sort of there's these reaching for methodologies for how to do it, is what it feels like to me. And some of it's pseudoscientific, some of it is, but between that and also the Thomas Kuhn and his revolutions of science stuff, there's sort of I'm getting a little bit slightly more familiar with the language people have been using to try to talk about this stuff. And I think it's relevant to the Cognition Futures projects in general, but also some other project and things I'm working on. But with that said, Plot Tricious is still kind of in vacation. The person who I want to do the philosophy of history science project with specifically is also like, you know, August vacation period is coming to an end now. So maybe more about that in the future, but that's basically the crux of my updates for now. So we can move on to other things.
All right. That sounds great. Thank you for the update. And yeah, I look forward to hearing more about your. I guess it's like the use of theory, or what is it?
Yeah, and there's a nice. I really think that the discussion we had towards the middle and later half of the human use of human beings was interesting in light of it too. And I need to just make. I know I always say this, and I'm just saying it to kind of continue to echo to myself. I have to continue to put the things into writing that other people can see, because I'm both different project scopes, but different excuse me, different ideas. Like I haven't totally finished the blog post I started at the last full Cognition Futures meeting. Was a little bit about the difficulty, and the title, if you remember, was something like, I sort of excerpted or sort of quoted the phenomenologization of nature, or the naturalization of phenomenology, and sort of the interplay between, which way are you going? First person, third person, first person, sure, but also, I didn't. This is. I'm so glad I remember this, because what I put in for later in the chat was Evan Thompson book, which is directly related to this, because Evan Thompson is doing a sort of philosophy, history of science-ish book, and I will. If I share this on this screen, can you? Nope, I don't think you can see it yet. Hold on a second. Let me. Oh, I'm not sharing my screen at all, am I?
No.
Okay, cool. That's totally okay. Let me just move this around first. There we go. Yeah. And I'll put this over here so we can see it. Nope, that's not the one I want to go to. Okay, sorry. I meant to say this. I'm glad I remembered to say this, because we're talking about. You can see this now, though, I believe. Yeah. Okay.
Oh.
So, Amanda posted this book. I saw you mention this channel, but I don't know if you talked about this book earlier. I don't think you did. The Blind Spot book. It's Evan Thompson, but it's Evan Thompson on and others on a new scientific culture that views ourselves as both as an expression of nature and sources of nature's self-understanding. The blind spot, the illusion of absolute knowledge, reframe how science worked for the sake of future in the face of planetary climate change. So it feels kind of a bit in line with a lot of the things that maybe I was looking at Evan Thompson's book on like something about like dreams or whatever, and I think Evan's a little more into the mysticism of things, and a lot of, I know Varela did is inspired by Buddhism too, but I think Evan's very on that side of things. So I'm curious. I haven't seen like a table of contents of it yet, but I'm curious how it is. But I think it's a legitimate sort of like Varelian lineage of centering experience more is quite relevant to this. So Amanda shared this book in the Cognition Futures, and I think I had this side comment from what I was reading about was this the one I'm thinking of? One element of this contention. This is okay. So this is from the end of his book, The Open Society and Enemies, in the conclusion part, and it says, "Whoa, that's a little too much. You might not be able to read this. I'm sorry." One element of this contention remains true, that all scientific description of facts are selective. And he talks about searchlight theory of science, the bucket theory of mind. What the searchlight makes visible will depend upon its position, upon our way of directing it, upon our intensity, color, etc. Although it will, of course, also depend largely upon the things illuminated by it. Similarly, scientific description will depend largely upon our point of view, interests, which are, as a rule, connected with the theory or hypothesis we wish to test, although also depend on the facts described. And so on. And it's basically, I think there's a line to be drawn from this to kind of what the blind spot's getting at, and to this. It's an interesting link between this and like phenomenology itself, and sort of the problem, and the way we're dealing. There's sort of this. There's something I'm trying to sort out how to talk about in terms of what. There's sort of this. This view externally to the sort of cultural, there's later one person, the third person. I get, maybe a good way to say it is actually Fuchs's horizontal and vertical causality versus like intra-organism versus organism environment. I think there's some things to be sorted out with sort of what Carl's getting at here. I'm not saying Carl's doing phenomenology, no, but I think there's sort of some relevant overlaps in terms of the perspectives trying to be pushed forward in how we're viewing the development of stuff here, and then also, I'm really curious how much this book that comes out next year. Which just to be supposedly next March, how much will that actually tie into sort of basically what we're trying to do with the Varela's quest line we're following in the Cognition Futures space. So I'll leave it at that. I think that was the segue I kind of missed before, but to be continued. Yeah, that's it.
Yeah, thanks for that. That's great. So yeah, there's a lot of stuff we've been talking about with and Amanda had a comment in the chat where she said, my first philosophy class was on philosophy of science, and I just found the syllabus. I put it in the Notion, a good reading list. So this is in the Notion.
Oh.
Yes, it's down here somewhere.
There's one other thing. Yes, I saw her put it in the new business. Which I'm not showing my screen anymore, but that's okay. There's one other thing I would say, but it's a tangential topic, and I'll just say it quickly, and then we can go on your closing papers. I got a bunch of really good resources on autoethnographies, because I'm in a grad school discussion research server, and I'm not really I'm not going to draw any lines to other projects right now, but there's I think there's, and I think to some extent even like on becoming aware was almost partially autoethnographical work on trying to develop the theory about phenomenology. And by autoethnography, I mean like people trying to document their personal experience as they're doing, in this case, like a research work or whatever, or trying to study a phenomenon, which in this case is developing like this theory. I feel like, I guess what I'll say very briefly about that is like, I'm finding, it came up originally through plot twisters because we wanted, like, someone's like, oh, we should do this because we're developing kind of a new sort of like organizational way of doing things in plot twisters. So let's make it autoethnography about it, kind of a thing. And that was cool, but then I realized I think there's an important component of this for what I want to do with a lot of things, but also some elements of the Cognition Futures in general. I think it's become a little more clear that writing specifically and intentionally about that personal experience and the work, almost like the behind the scenes look of it, which I feel is a little, it's sort of like, as I know Raj isn't here anymore, but I think there's an element to it in the Google Summer Code discussions about documenting. Like documentation is nice, but also like how do you document headspace? I think formalization of that process with all ethnographic lens and flavor around the Cognition Futures and other things will be kind of important, just to just for just certain like landmarks too. So more about that later. I had a really good. Maybe I can just. It's not letting me show this. I'll just briefly put this on camera and then I'll be done.
Okay.
This paper was recommended to me. It's a really good introduction to a lot of ethnographic autoethnography stuff. And then there's a whole other like list. I can't show the Discord server right now, but there's in the server there's a bunch of people who have done these practices, which is quite helpful. But it's interesting, and I actually I might show this to Amanda later and get your take on it because it covers some philosophy stuff. They have these different names here, even like Derrida and these other names here. Conquer Good's a badass name, by the way. But like I was inspired by that. But there's a lot of like, I was kind of impressed by the lineage, even like the crisis of confidence, postmodernism, and sort of this. There's a lot of like cultural zeitgeist and frontier mapping related things here that I'm quite interested in. All the different names here. So a teaser for next time, but I think I'd like to explore some of the philosophical implications of that in terms of some of the other work we're doing. So yeah.
Yeah, that's great. Thanks for that. So that actually that paper is in the Slack. Which channel is that? Cognition Futures, I think.
This ethnography one is not. This is. I can put it there, but
yeah, I saw it somewhere. I don't know where it is. But yeah, that would be good.
Yeah, I will put it there.
All right. So let me get into some. Let's see. What do I want? Oh, we gotta. Oh yeah. Hussain's first philosophy class was on logic. Okay, so
yeah, we wasn't exposed until undergrad actually. I know some people studied philosophy in high school, and I'm like, that's really, really interesting. So yeah.
All right. Let's see. I'm gonna do a couple of papers I've been sitting on for a while. It's just kind of like I haven't had the chance to present them, but I'll present them now. So this is about a couple topics, and I'll just call it sort of as a category, action, touch, and crosstalk. And so crosstalk is where you have different pathways. It could be like molecular pathways or brain pathways that interact in some way. So we usually think about the brain as a set of pathways, and that we go from like one end to the other. So we have like something that's an input, a sensory input, and then a sensory output, and it gets processed in the middle. And then we talk vaguely about interactions, but sometimes we can identify pathways or circuits, and then that's the sort of the way it looks. Crosstalk is where you have these pathways that are independent, but they interact at certain points. And so like there's a lot of literature on like molecular crosstalk or on brain circuit crosstalk, and it's different. I guess it's a way to talk about interactions in that mechanism, but we'll look at what the example from the cerebral cortex later. This is though a paper that talks about action and touch, and so this is this is about motor control. So this is about the motor control pathway and what happens during motor control. You perform actions in the world. You touch things. You get feedback. That feedback goes into the nervous system. Then that pathway basically processes that input and verifies your percept. And then you're looking at something with your eyes. You're touching it. There's feedback, and so that's where we are with this paper. So this paper is called Action Does Not Enhance, but Attenuates Predicted Touch. So
if you're sharing your screen.
Am I sharing my screen? Okay, let me share my screen, yeah. Okay, thank you. So this is Action Does Not Enhance, but Attenuates Predicted Touch. So the model I talked about before, we had where I'm looking at something, I'm touching it. The touching is enhancing my view of it. It's verifying the view. That's what we're talking about. This is actually where it says it attenuates touch. So it's a little bit different way of thinking about it. It's like instead of, action being like, action meaning like reaching for a cup and using your senses and giving a behavior output. So there's that. That's what the difference is there. So the abstract reads, dominant motor control theories propose that the brain predicts and attenuates the somatosensory consequences of actions. So that means that I'm acting in the world and I touch things, and the touch provides some information as feedback, but how does it actually work? Does it enhance or does it attenuate what I'm doing? So this is referred to as somatosensory attenuation. So if you you touch things like walls, or you touch the ground, or you touch the grass, as they say, those are all attenuating your somatosensory action. Support comes from psychophysical and neuroimaging studies showing that touch applied on a passive hand. So if I just lay my hand out and I touch it, it elicits attenuated perceptual neural responses if it is actively generated by one's other hand. So I can do, like, I don't know if you can see my hand here where I'm touching it, like this with my other hand. Compared to identical touch from an external origin. So that would be if someone else's hand were touching my hand. It's a different thing. It's qualitatively different, but also maybe quantitatively different if we measure the nervous system as it's happening. However, recent experimental findings have challenged this view by providing psychophysical evidence that perceived intensity of touch on the passive hand is enhanced if the active hand does not receive touch simultaneously with the passive hand. So the active hand being, I guess, if you had two hands and the active hand is receiving something, the passive hand is also receiving something. So there's a simultaneity of it that needs to be there. So this is enhancement. And by further attributing attenuation to the double tactile stimulation of hands upon contact. So this is where you're stimulating both the hand that's receiving the signal and the hand that's giving the signal. Here we directly contrasted the hypotheses of the attenuation and enhancement models. So these are two models of interpreting this phenomenon regarding how action influences somatosensory perception by manipulating whether the active hand contacts the passive hand. So this is where you can manipulate the sort of the contact point in the feedback. We further assess somatosensory perception in the absence of any predictive cues in a condition that turned out to be essential for interpreting the experimental findings. In 3 pre-registered experiments, we demonstrated that action does not enhance the predicted touch. So this is where you have action, it either enhances or it attenuates predicted touch. So there's a prediction of touch. That's experiment 1. That the previously reported enhancement effects are driven by the reference condition used, and that self-generated touch is robustly attenuated regardless of whether two hands make contact. Our results provide conclusive evidence that action does not enhance, but attenuates predicted touch and prompted reappraisal of recent experimental findings upon which theoretical frameworks proposing a perceptual enhancement by action prediction are based. So this is, I don't know if we talked about predictive processing last week. We did. In the second paper in our final discussion of the meeting. But this is like basically this whole paradigm where you're sort of enhancing your experience with your actions with touch is, about predictive processing. In other words, I can predict things in the environment, I verify them. That's predictive processing. But this actually challenges that in a number of ways. So I'm not really clear on I don't know, it's kind of fuzzy in my mind as to how this works or how this maps to action. But so the highlights are dominant motor control theories propose that action attenuates or cancels predicted touch. So this is a motor control theory where that's the prediction. Recent theories propose that action enhances predictive touch. So this is where action is enhancing predicted touch. We show that the action does not enhance but attenuates predictive touch. So those are the highlights. So dominant motor control theories propose that the brain uses an internal forward model. So an internal forward model is where you have an internal model of what's going to happen in the world, and you try to use that to predict what's going on. So there's a forward model, which means it doesn't have feedback. You're basically saying it's an internal model. You're making a prediction about what's happening in the environment. That's how you perform your action. So this is the model that's used in combination with a copy of the motor command or an efference copy to predict the sensory consequences of our movements. So this is basically it's a representation that people think is happening, and people have used internal models in robots as well as in predicting what the motor or what the nervous system will do in a certain situation. So you have this internal forward model, which it's a forward model, meaning that it predicts things in the future or it predicts things outward. There's a forward model and there's an inverse model. So the inverse model is predicting, if you were to look at a process in the world, you would try to predict what that process, what the mechanisms were, how it worked. A forward model is to generate some action. And so that's what they mean by forward versus inverse model. And then there's this copy of the motor command, meaning there's this theory of the efference copy. This goes back to Sherrington, where there's a copy of what happens in the nervous system that it's basically feedback to predict the sensory consequences of our movement. So those are the two kinds of things that's what theory predicts. So it's not predictive processing in conventional predictive processing, but I think it's consistent with it. For example, the brain predicts the upcoming touch as one reaches towards an object. These predictions allow for the correction of motor errors without relying on sensory feedback that suffers from intrinsic delays. So you reach out towards an object, you predict what the touch will be. Those predictions then can be done in lieu of correcting motor errors. So instead of trying to correct motor, in other words, if I reach out for a cup and I touch the cup and I lift it up, I have to make a prediction about the pressure that I'm using, the force that I need to get to the cup, and that I have it in my hand and I'm going to lift it without spilling it. That's what I need to do. And so, there's one way to do this, which is to get the arm out there, put the hand around the object and grab it and move it. If you wait for motor errors, if you wait to evaluate every motor error or every thing that might be off from that model, from that forward model, then it's going to take too long to do it. It's going to be very slow and jerky and everything else. So what happens is that we think that the nervous system actually can predict what those errors should be and then predict them on the fly. So that's what they mean by this. And so this is it's a strategy to circumvent delays that might occur. So the movement is smooth, it's faster than it would be if you were trying to do a model where you just made an action and then tried to correct the errors through feedback, through a more conventional method of feedback, which is visual feedback, touch feedback. So you would have to touch something to verify. You would have to verify with your vision, and you would have to integrate all that information. That would take too long. So this is something where, there's this model where, okay, you do this prediction, you have this forward model of movement, and that's how it's generated. And so that improves our estimation of the current state of our body by combining the predicted touch with the actual sensory input. These predictions attenuate the perception of self-generated input, so it's a sensory reafference compared to that of externally generated input, and it allows us to infer whether the cause of the sensory input is the self or the environment. So we can infer those things as well. A classic example of this attenuation is that we are unable to tickle ourselves with our own touch, yet we're easily tickled by the touch of others. So this is where this experimental paradigm comes from. So I guess I don't know why that works. We can't tickle ourselves, but we can easily be tickled by the touch of others, because I guess we're thinking too hard about tickling ourselves or something. There's something about using another frame of reference to do this. So when I was talking about touching the hands with your own hand versus another hand, that actually affects the mental model or the neural model of this experience. The attenuation of sensory reafference, also referred to as sensory cancellation, is thought to be necessary to compensate for the limited capacity of sensory systems by optimally prioritizing the perception of more informative external generated stimuli. So basically, we can't tickle ourselves because we attenuate ourselves out of it. We expect this thing to tickle us so we don't respond in the right way. The tickling actually happens if you have someone else stimulating and we don't have a model of that, in the same way that we have a model of our own actions. So that's kind of an interesting way to approach this. And then, of course, you can do this just by touching a hand, touching the surface of the hand, and that's a very simple way to do this experiment. Thus, the attenuation model proposes that we dampen perceptual representations of expected self-generated stimuli. So we dampen those representations. This is done to reduce redundancy and to highlight behaviorally relevant, unexpected, externally generated stimuli. So this is actually a way to highlight surprise or unexpected things that happen. So you can imagine if there was an unexpected thing when you're reaching out for a cup, someone smacks into your arm, and you can't predict that because it's just a random thing that happens. That's something that's surprising and that you have to respond to. So that's something we want to highlight. But maybe the risk of doing that even. But that's why that works. And so there's attenuation there of our own actions versus other actions imposed from external sources. So in contrast, an alternative theoretical framework proposes that predictions, including those arising from our own motor commands, should not attenuate, but instead enhance sensory signals, thereby allowing for sharper, i.e. more accurate representations of predicted compared to unpredicted sensory events. This enhancement account, also referred to as the sharpening account, posits that predictions based on our motor commands are equivalent to expectations formed by statistical regularities in sensory input or from prior knowledge. So this is where we have, I guess, what's consistent with this is the Bayesian view of the nervous system. That is, we have this prior, and we're making sort of a prediction based on the prior, and we're getting empirical information in all the time, and we're updating the prior. So we have these statistical regularities which form a statistical prior. We can use that to predict our movements, and the data coming in or the sensory input coming in enhances that prior, or it enhances the performance in the prediction, and so forth. So at the North Pole, one expects to see a polar bear rather than an elephant. Our prior is that polar bears exist at the North Pole, elephants don't, or at least are more likely to or not. And then that's what you should expect to see. And if you see that, then it confirms and it enhances your experience of that. If you see an elephant, I guess it does not enhance your experience of that, and so forth. That these predictions should bias our perception towards our expectations. This proposal mainly stems from an experimental research paradigm outside the domain of action and argues that weak, noisy, or ambiguous sensory input is in line with prior expectations, or that weak, noisy, or ambiguous sensory input that is in line with our prior expectations should be enhanced to achieve, on average, more accurate representation. So you refine your representation with these expectations from the prior, and if they're verified, then that's even more enhancing to that. So these are the two models. So they're arguing that this first model is what we experience. And so that moves us to this idea of crosstalk. And so this actually sets this up because we have this sort of model of prediction and enhancement by confirming our priors. And then we have this idea of having a forward model that enhances surprise and things like that. So we don't actually use environmental information to confirm our priors, but to sort of stand in contrast to our priors. So that's what they're getting at there. But it also has to do with crosstalk, because in crosstalk you have these interactions between pathways and things that we expect them to behave in a certain way. So there are these interactions that actually are unexpected events, and so we have to think of this in a different way than we think about like pathways of sort of these processes that happen. So this is that's a little bit outside the scope of this paper, though. This is a review on shaping the cerebral cortex by cellular crosstalk. In this paper, the summary reads, the cerebral cortex is the brain's outermost layer. It is responsible for processing motor and sensory information that support high-level cognitive abilities and shape personality. Its development and functional organization strongly rely on cell communication that is established by an intricate system of diffusible signals and physical contacts during development. Interfering with the cellular crosstalk can cause neurodevelopmental disorders. Here we review crosstalk between migrating cells and their environmental influences, cerebral cortex development, ranging from neurogenesis to synaptogenesis, and assembly of cortical circuits. So this is removed from like a representational view of what the brain's doing. And it's kind of getting down into some of these, cellular mechanisms and intracellular mechanisms. And so this is their definition of crosstalk here, is where there's this necessary crosstalk between systems and between cells, and it's critical for their proper development. So the cerebral cortex is an advanced brain structure. It has an intricate organization. It has this orchestrated migration of neurons and glial cells, and they settle into organized layers within the cortical wall. They form neural circuits, and these are essential for higher cognitive functions, as they say. During embryogenesis, some neurons and glial precursors navigate towards the cortex by following common migratory routes. So there's this pathway that's a sort of a canonical pathway that these things happen. Comparative studies show that some of these mechanisms are highly conserved. So this is very canonical across species, and so we know that this happens, and it's important for its function, its proper function, that this happens. And then, while navigating into the cortex, they contact neighboring cells and read extracellular cues to integrate cortical circuits. So a crosstalk is established between cortical interneurons and dorsocortical progenitors via diffusible molecules. And so this controls different things, different processes that need to happen. In addition, the interaction between these two types of cells provokes the survival of one type of cell the CINs, which are the cortical interneurons, and provides them with, where am I here? And provides them with the things they need to survive. So that's something. It provides them with spatial information to integrate into cortical networks. So they need this to survive, but they also need to integrate themselves into a network. Some glial cells also promote transient crosstalk with neurons, as exemplified by these established between CINs and oligodendrocyte precursor cells. And so there's this, there's this role for crosstalk in these developmental things. Accumulating evidence supports the disruption of physiological cell interactions in the developing brain or the emergence of deleterious crosstalk. And this contributes to the onset and progression of neurological disorders. So these interactions are actually important for proper development, not just the canonical pathways. If they're disrupted, they can lead to disorders. We need to understand these processes to better understand sort of how the brain repairs itself and how it organizes itself. So they kind of talk about crosstalk and development. They talk about different secreted cues during cell migration in cortical morphogenesis. So there are whole sets of biomolecules that we can pay attention to, like IGF-1 signaling and CTCL12 signaling. And so this is just a diagram of these different things here in the context of the neocortex. So you have these different levels in development of the ventricular zone, subventricular zone, the intermediate zone, the cortical plate, where these cells migrate through. And they just show how they connect through these different layers and, the relationships of signaling in these areas. And then RELN expression is also important. Then they talk about transient intercellular contacts during cell migration and cortical morphogenesis, their receptor ligand interactions, their intercellular adhesive contacts, and there's also cellular crosstalk and cortical circuit formation. So the formation of circuits isn't just like putting the circuits together according to some sort of like master plan. I mean, there is sort of a master plan in some way that cells need to know where they need to go. That there's some sort of predetermined aspect there, but you also need the cellular crosstalk for it to happen properly. And so this just talks about some of these crosstalk mechanisms. And when they say crosstalk here, they mean like signaling between pathways and between cells to organize certain pathways. And so this is one example. There's also an example from the function of neural circuits where information is crossing. There's a lot of crosstalk. And I guess one way you could think about that is in the context of multi-sensory integration, which we won't talk about today, but that's another example maybe of this idea of crosstalk. So there are a lot of broad ideas that I kind of hit on in this overview. So I think it's something to maybe talk about later or chew on and think about. So yeah, gonna head out soon. May try to listen. Thank you for doing so much in the Notion, Amanda. So thank you, Amanda, for putting your contributions in Notion. I have to look at that syllabus. It looks interesting, especially the diagram at the top. I didn't mean to like rearrange your stuff. My computer is being glitchy. Yeah, it's fine. So yeah. So that's all I have for today. Any comments or questions before we end?
So the cerebellar the cerebral crosstalk that you've just described in that paper.
Yeah.
Is that relevant to any particular project that's going on right now?
Well, no. I mean, the brain development stuff. I mean, I think we've talked about that in DevoWorm from time to time, and we've done things in DevoWorm with like the C. elegans developing connectome. So like C. elegans is different than that, and there is a lot of crosstalk in what we call connected genesis and C. elegans, and C. elegans is a tractable system where you could look at that. We have data on that, but that's something that we've talked about from time to time in that group. But yeah, it's not something we're exploring actively as like a specific topic. So
Okay.
I know you've talked about wanting to know more about diva worms, so I don't know. We can still I don't know, maybe if you ask me questions about what's going on in diva worm, I can give you better answers than if I just had to describe it.
Yeah. We can keep in touch with that.
All right. Yeah, sounds good. Okay. Well, any other comments? Okay. Yeah. Thank you, Amanda. All right. Well, thank you for attending, and talk to you next week.